Good morning. So we were discussing ideal and non-ideal solution. Okay, and we have discussed ideal solutions. Okay, so what are ideal solutions? I told you ideal solutions are those solutions. Okay, those solutions which strictly obeys Raoult's law. Which strictly Raoult law. Okay, means P total should be equal to A0 XA plus P0 PA0. Okay, where this total is experimentally calculated. This is experimentally calculated, and this PA0XA plus PA0XB, okay, is from Raoult's law. Getting this? So when experimentally calculated total vapor pressure of a solution will be equal to sum of vapor pressure of component A multiplied by its mole fraction plus sum of partial vapor pressure in pure form of the other component multiplied. Okay, that is it has come from Raoult's law. So when experimental calculation will be equal to Raoult's law calculation, okay, then we say it is obeying Raoult's law. Then we will say it is obeying Raoult's law, and if it obeys Raoult's law, then we say it is ideal solution. Second thing I have told you, second point I told you, to be an ideal solution, okay, delta V mixing okay, should be equal to 0. Getting this? I told you delta H mixing is equal to 0. I told you, and it is most important point, that is AA interaction should be equal to BB interaction should be equal to AB interaction. Okay, and I told you this point is the most important point. This point is the most important point, means AA interaction BB interaction should be equal to AB interaction, where AA is the interaction between particles of one component, BB is the interaction between the particles of other component, and AB is the interaction between particles of two components present in the solution. Okay, so these are some we say conditions, okay, to become an ideal solution. Okay, now we will be discussing graphical representation of an ideal solution. Okay, so put heading graphical representation. graphical representation of an ideal solution. Okay. We have two equations. We know if there are two components A and B, okay, if A and B are two components present in the solution, two components present in the solution, then according to Roult's law, PA will be equal to P naught or PA0, okay, XA, and PB will be equal to PB0 XP. Getting this? So say this is equation 1, say this is equation 2. Okay. So from these 2 points we can say this is partial vapor pressure of component A, this is partial vapor pressure of component B. So we can say partial vapor pressure of a component, partial vapor pressure of a component present in a solution is linear function of its mole fraction. Getting this or not? Using these two equations we can say PA is equal to PA0 XA, where PA0 is what? PA0 is the vapor pressure of the pure solvent. Getting this now? So we can say this partial vapor pressure of component A or partial vapor pressure of component B, okay, present in the solution, both will form a solution, okay, is linear function of its mole fraction, linear function of its mole fraction. Getting this or not? Okay, so we will write here XA XB XB. This is the graph of vapor pressure and mole fraction. This axis is showing mole fraction, this axis is showing vapor pressure. So I am writing it here. This axis is showing vapor pressure. Okay, so we have two equations, equation 1 and equation 2. Okay, we have to plot these equations in terms of graph. Okay, so look at equation 1. Here if XA will be 0, we have PA is equal to PA0 XA, and I am saying here XA is 0. So if you will put this term 0, Okay, then whole term means PA will become equal to 0, means graph will originate from this point. Okay, when we will say XA is equal to 1, when we will say XA is equal to 1, means mole fraction of component A is equal to 1. What does this mean? It means only one component is present in the solution. If mole fraction is 1, then only one component, okay, is present in the solution. So we will say what? We have PA, then PA will be equal to PA0 into XA, and in place of XA we are going to write 1, because if only one component is present, then mole fraction will become 1. So it will give you PA is equal to PA0. Getting this now? PA is equal to PA0 when only one component will be present, or mole fraction will be XA will be 1. So we will say the graph will be like this, and here it is showing PA0. This point is PA0. Okay, why PA0? Because XA, when you will put 1, then whole term will become equal to PA0. So this is the graph, okay, of PA. This is the graph of PA is equal to PA0 XA. Okay. Now put XB is equal to 0 in equation 2. Put XB is equal to 0. So if XB is equal to 0, okay, put here, and here XA is equal to 1. XA is equal to 1. Now once you put XB is equal to 0, so if you will put XB is equal to 0, means what? We have PB, okay, we have this PB is equal to PB0 XB. When this XB will be 0, then whole term will become 0, means graph will originate from this point. And when you will put XB is equal to 1, means only component B is present this time. Okay, so you will get here PB will be equal to PB0 into 1, or simply PB is equal to PB0. So when XB is equal to 1, XB is equal to 1, so say here, write here okay, it will be like sorry, it will be like this, and this point is PB0. When XB will be 1, it will become PB will become PB0, so it is PB0. Getting this? And this graph is showing, this is showing PB, it is graph of PB is equal to PB0 xp, pb0 xp. Very good. So these two graphs, okay, these two lines, okay, are graphs for component A, graphs for component B, and when you will combine these two, okay, when you will join these 2 points, uh, okay, so this will give you P total. This will give you P total, and it is equal to PA0 plus, sorry, PA plus PB. Okay, and we can say this is vapor pressure of solution. This P total means vapor pressure of both components, and both component will form solution. So we will say vapor pressure of solution. Okay, so this is the graph of ideal solution. Okay, this is the graph of ideal solution. Okay, now come to non-ideal solution. Okay, now come to non-ideal solution. One thing which is important, okay, okay, this P total is always in between PA0 and PB0. This P total, this is what? PB0, this is what? PA0. So this graph, okay, of P total lies between PB0 and PA0. So write it here. The vapor pressure, the total vapor pressure or the vapor pressure of the solution, or the vapor pressure of the solution, okay, always lies in between, okay, PA0 and PB0. What is PA0? PA0 is the vapor pressure, okay, of component A in its pure form. Just try to remember, okay. What is PA0? PA0 is the vapor pressure of component A in its pure form. Vapor pressure, VP, vapor pressure of component A in its pure form. And PB0 is vapor pressure of component B in its pure form. So total vapor pressure of solution will always be less than vapor pressure of component A in its pure form, and vapor pressure of component B in its pure form. Okay, this is indicating this graph. One more thing. probably you will be doubting, sir, one PA0 is placed below and PB0 is placed above. Okay, so why we are doing so? Okay, so for this I just want to tell you, there are two components, component A and component B. We don't know which one is more volatile. We are just assuming here. Okay, if PB is more here, it means what? It means component B is more volatile here. So if it is more volatile, means more of the vapors are forming, and if more of the vapors are forming, so more, okay, partial vapor pressure is being exerted. That's why here PB0 is placed up as compared to PA0, and PA0 is down. It means what? It means it is less volatile than B. Component A is less volatile than B, and since it is less volatile, it means less of the component A are evaporating, so less vapors are being formed, so less pressure, less partial vapor pressure is being exerted by component A. So it is up to you. Okay, you if you wish, you can write here PA, PB here. So don't worry. Okay, we don't know which component is more volatile and which component is less volatile. So it is up to you. Okay, you can place any of the two components, okay, below or up. Okay, now come to non-ideal solution. Non-ideal solution. Now you can understand it, okay, very well. It is opposite of ideal solution. Okay, so let's start. Let's define it first. What is non-ideal solution? Non-ideal solutions are those solutions non-ideal solutions are those solutions which do not obeys Raoult's law. Getting this? What are non-ideal solutions? Non-ideal solutions are those solutions which do not obey Raoult's law. Means, what is Raoult's law? Raoult's law is, if there are two components A and B in a solution, so PA will be partial vapor pressure of component A, and it is given by PA0 XA. PB will be partial vapor pressure of component B, and it is given by PB0 XB, and total partial pressure P total, or partial pressure, pressure, vapor pressure of solution will be sum of P and PB. Okay, PA and PB. I told you this is experimentally calculated. Okay, and this is calculated by Raoult's law. Okay, so very simple. If it is not obeying Raoult's law, and we know Raoult's law means these three equations, so we have to simply say PA is not equal to PA0 XA, PB is not equal to PB0 XB, and P total is not equal to PA plus PB. Getting this? So this is the first point. Second point will be delta V mixing delta V mixing is not equal to 0. Third point, delta H mixing is not equal to 0. Okay. Fourth point we will say AA interaction is not equal to BB interaction is not equal to AB interaction. Getting this? So this is called as non-ideal solution. Okay, very good. Now there is one comparison between ideal and non-ideal solution, and it is important for your examination. Okay, board examination. So I am rubbing these things. Okay. So it is ideal solution versus non-ideal solution. Versus non-ideal solution. Versus not means it is difference. Okay. Non-ideal solution. Okay. So ideal solutions are those solutions which obeys Roult law. Okay, very briefly we will be discussing these things. Okay, first point we will say obeys Roult law, obeys Roult's law strictly. Okay, non-ideal solutions means do not obey Roult law, do not obeys Roult's law. Second point, delta V mixing is equal to 0. Here delta V mixing is not equal to 0. Delta V mixing is not equal to 0. Third point, delta H mixing is equal to 0. Here it will be delta H mixing is not equal to 0. Fourth point, AA interaction is equal to BB interaction is equal to AB interaction. It is AA interaction is not equal to BB interaction is not equal to AB interaction. Okay, so these are some differences between ideal and non-ideal solution. Okay, and I told you ideal solutions are basically those solutions which are very much diluted. Very much diluted means which are less means more than say if there is 100 ml solution, then only 5% will be the solute and rest will be the solvent. Getting me? Means much more diluted solutions. Okay, diluted solutions are treated as ideal solution. It is very difficult to get ideal solution. Okay, but when the solution is very much diluted, we consider it to be ideal solution. Now come to non-ideal solution, types of non-ideal solution. Okay, types of non-ideal solution. Okay, there are two types of non-ideal solution. First one is non-ideal solution showing non-ideal solution showing negative deviation from Roult's law. Showing negative deviation from Roult's law. And second is non-ideal solution showing positive deviation from Roult's law. Getting this? Okay. So two types of non-ideal solutions are there. Okay, first one is non-ideal solution showing negative deviation from Roult's law, and second one is non-ideal solution showing positive deviation from Roult's law. What does this mean? Simply, I told you P total is equal to PA0XA, or simply say it PA plus PB. Okay. It is ideal solution. When it do not follow the ideal solution, means it is not equal to, P total is not equal to PA plus PB, means we will say it may either greater than or less than. It may either greater than or less than from this value. So if P total is greater than PA plus PB, we will say it is non-ideal solution showing positive deviation from Roult's law. And if P total will be less than PA plus PB, then we will say, okay, it is less than now, so we will say non-ideal solution showing negative deviation from Roult's law. Okay, so put heading non-ideal solution showing negative deviation from Roult's law, and just try to understand this thing. It is non-ideal solution showing negative deviation from Roult's law. So first thing is P total is less than negative deviation now, so it is less than PA plus PB. Second point we will say not only this, we can also say PA is less than PA0XA. We can also say PB is less than PB0XB. This is first point. Second point, we will say delta V mixing okay, is negative. Third point, delta H mixing is negative. Fourth point will be, now just try to understand. Fourth point is the key point. Okay, so just try to understand, okay, these things. Okay, so if delta V mixing is negative, okay, it means what? I have told you earlier, say it is component A, it is component B, and both are forming solution AB. Okay, so delta V mixing is negative. Means it is less than 0. Means it is volume of solution Vs. Okay, and volume of solution is less than, okay, volume of component A plus volume of component V. So Va plus Vb. Okay, it means Vs is less than Va plus Vb. Means in which case volume of component A will be more? When AA interaction is more or strong, and BB interaction is strong, but AB interaction is weak. Okay, but it is V mixing is equal to negative. Okay, sorry, AA interaction is weak here, na, and BB interaction is again weak here. Okay, so if interaction is weak, means particles will be, okay, at more separation. Particles will be present at more separation. So if particles will be at more separation, means volume will be increased. So it will have greater volume. Again, same case will be in case of component B. Weak interaction, so volume of component will be more. So more volume. Simply we will say it is having more volume and it is also having more volume. Okay, now AB interaction is strong. Getting the point now? Here A interaction is weak, BB interaction is weak, but AB interaction is strong. So if AB interaction is strong, means they will be, okay, present closer to each other. Getting this now? And if they will be present closer, okay, then their volume will be decreased. Getting this now? So it will result in decreased volume of the solution. It will result in decreased volume of the solution. Decreased volume of the solution. Now you can just see here, okay, volume is more here, so more volume plus more volume, and resulting volume of the solution is less. So we will say Va plus Vb is greater than Vs, or Vs will be negative. Means what? In terms of interaction, we will say AA interaction is, okay, is more, right here, AA interaction, AA and BB interaction, AA and BB interaction is more than AB interaction. So this is the key point. Point fourth is the key point. Okay, AA interaction is more than BB interaction, and due to this is happening. Now come to this delta S mixing is negative. What is significance of this? Okay, delta S mixing is negative means what? Negative means what? Here it is exothermic process. Okay, if it is negative means it is exothermic process, you know it. So it is exothermic. It is exothermic. Why this is exothermic? AA is weak. AA interaction is weak. So less energy is needed. Less energy is needed to break AA interaction. BB is weak. So less energy is needed to break BB interaction. But this AB interaction is strong. So if AB interaction is strong, then due to the strong interaction, we know attraction causes release of energy. So because here interaction is strong means attraction will be strong, and if attraction will be strong means more energy will be coming out. Getting this now? So energy required to break AA interaction is less, energy required to break BB interaction is less, but energy released, okay, energy released during we say attraction between AB particle is more. So net energy, okay, net energy is negative means net energy is we say given out, okay, during the dissolution process, and that's why it is exothermic and it is coming out to be negative. So this is the non-ideal solution showing negative deviation from Roult's law. Okay, 4 key points are here. Okay, P total is less than PA plus PB. Okay, PA is less than PA0 XA and PB is less than PB0 XB. Second thing, delta V mixing is negative, delta S mixing is negative, and AA interaction and BB interaction are weak as compared to AB interaction. Take one example of this. Okay. शैडो बन रहा है तेरा. Okay, example of this type of we say ideal non-ideal solution will be, okay, having weak intermolecular or weak van der Waals forces, okay, molecules having weak van der Waals forces, okay, forming solution, and the solution in the solution say hydrogen bonding will be formed. Getting this now? Means one component is having van der Waals force of attraction in between them, other component is having van der Waals force of attraction between them. Van der Waals force of attraction is weak, okay, van der Waals force of attraction is weak, we know it, okay, and resulting solution will be having, okay, hydrogen bonding, say hydrogen bonding which is of more strength. Okay, so in next lecture we will be discussing a graphical representation of, okay, ideal non-ideal solution showing negative deviation and positive deviation, and we will be discussing azeotrophs. Okay, thank you.